At about 8:43 in the morning, the Coast Guard cutter Itasca heard Amelia Earhart transmit 6 numbers, 157, 337. They can look like coordinates. They were not. They described a line, and a line can cross thousands of possible locations. That distinction is the center of the disappearance. Earhart and navigator Fred Noonan had reached the final hours of a long flight toward Howland Island. The ship could hear the aircraft. The crew could not turn those contacts into a usable fix, and the final message revealed the direction of a navigational line without revealing where on that line the Electra actually was. This is not an attempt to choose between every theory attached to Amelia Earhart. It is a reconstruction of the last radio evidence, what it tells us about the failed approach, and the exact point where the record stops. The destination was Howland Island, a tiny and remote refueling stop in the Central Pacific. The Lockheed Electra had limited range. If Earhart and Noonan failed to find Howland, they could not simply continue the planned flight and correct the mistake later. The approach was already becoming difficult. The Smithsonian's navigation history identifies headwinds that consumed additional fuel and clouds that interfered with celestial sightings. The crew had passed the Gilbert Islands, one of the useful opportunities to check position, in darkness. Their planned solution required several systems to work together: dead reckoning from speed and heading, celestial observations from Noonan, and radio direction finding near the island. None of those methods was useless. The danger came from uncertainty accumulating between them. A small error in estimated wind changes the aircraft's dead-reckoned position. Clouds can delay a celestial fix. A radio bearing can correct both, but only if the aircraft and ground station can exchange the right signal in the right form. Howland was not merely another waypoint. It was the point where those separate estimates had to converge on one visible patch of land. The Itasca waited near Howland to support the flight. Its radio log identifies Earhart's aircraft by the call sign KHAQQ. During the approach, operators recorded messages about communication trouble, an altitude of 1,000 feet, and a report that the aircraft was 200 miles away. Those entries are invaluable, but they require careful reading. A distance spoken by the aircraft is not the same thing as a position independently measured by the ship. An altitude tells us how low the Electra was flying, not where it was. Without a reliable bearing, the received signal still did not draw a point on the map. The larger radio plan also contained mismatched capabilities. The Smithsonian notes that neither Earhart nor Noonan knew Morse code, which was important to the ship-based direction-finding support arranged for the flight. It also describes limited preparation with the equipment carried aboard the Electra. The result was not complete silence. It was something more frustrating. The ship repeatedly received Earhart while effective two-way guidance failed to form. The distinction matters. The disappearance was not caused by one radio suddenly switching off. Information crossed the ocean in one direction, but the information needed to convert those transmissions into a safe approach did not reliably return. As the expected arrival time passed, the messages became more urgent. The log preserves reports of difficulty reaching the ship and of flying low. At approximately 8:43 a.m., it records the final communication from KHAQQ. We are on the line 157-337, followed by an indication that the message would be repeated. A fuller reproduced transcript adds, "We'll repeat this message on 6210. We are running north and south." The Itasca listened on that frequency, but no later transmission produced a usable fix. To understand why the final words did not solve the search, ignore the mystery for a moment and look only at the geometry. 157 degrees points roughly southeast, 337 degrees points in the opposite direction, northwest. Together they describe the two directions of the same straight line. Imagine drawing that line across a chart. Earhart could be at any point along it. She could be northwest of Howland, southeast of it, or on a parallel estimate displaced by accumulated navigation error. The phrase running north and south indicates a back-and-forth search, but it still does not provide the missing distance. One line is not a fix. A second independent line crossing the first could create a point. A trustworthy bearing from the island could also narrow the answer. But the radio direction finding system never produced the guidance the crew needed, and the final message contained no coordinate that searchers could simply enter into a map. The most famous clue in the Amelia Earhart case, therefore, does two things at once. It shows that the crew was still navigating and trying to bracket Howland. It also exposes the missing information that mattered most. After contact was lost, the Navy and Coast Guard launched an extensive air and sea search. The National Archives describes it as the largest rescue search of its kind at that time, and preserves a Navy report covering July 2 through July 18, 1937. But search effort and search precision are different. Aircraft and ships can cover enormous areas and still begin from an uncertain center. The last transmission oriented a line. It did not say where along that line the Electra had been, how much fuel remained, whether the estimated line passed through Howland, or how far navigation error had shifted it. Every additional hour then expanded the possibilities. If the crew changed direction, the line no longer predicted the next position. If the fuel estimate was wrong, the reachable area changed. The final radio clue could shape a search, but it could not define one small box. The selected official and museum sources do not identify a confirmed recovery of the Electra or a verified final position. The Smithsonian considers an ocean loss likely, while also acknowledging that the exact errors that caused the miss may never be known. That is a reason to keep probability separate from proof. A likely outcome is not a recovered location. An extensive search is not a measured final coordinate. And a later claim, however dramatic, is not established merely because the original record contains a gap. The last hours of the Amelia Earhart flight contain three different levels of certainty. First, the radio contact is documented. The Itasca log records the aircraft's call sign, its communication problems, its reported altitude and distance, and the final line of position message. Second, the navigation failure is strongly supported. The crew had to locate a tiny island after a long ocean leg while headwinds, clouds, equipment limits, and incompatible radio procedures reduced the available corrections. Third, the final location is unknown. 157-337 was not the coordinate people sometimes imagine. It was the orientation of a line without the point needed to complete the map. The most honest conclusion is also the simplest. Amelia Earhart's final message tells us why the search was so difficult. It does not tell us where the aircraft ended. The last clue was a line. The missing answer was a point. If you want another case where a famous story outruns the surviving record, watch the Flight 19 investigation next. The legend became enormous. The documented evidence is much narrower.